Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about floating solar. So let's dive right into it. Now first we have to understand what are the problems, that why the heck we are thinking about something as ludicrous as putting solar panel on water. Well, land is a limited resource, meaning its price is always going up and the availability is always going down. There is a fixed amount of land on this planet. So fundamentally that creates an issue. You may think like, what about desert? Deserts don't have flat land. You can't just go there and build there. Like you have to excavate a lot, or you have to lay down foundation that itself directly. So those are not easy. And on top of that, deserts are never accessible. That's why they are desert. If they are accessible, people will establish a colony there and then slowly a city would be there. So reality is land is a limited resource. So when Indian government is like, I want to build a 600 megawatt plant, okay, where you will get land? First time, easy problem. Second time, okay, bit difficult. Third time, yeah, good luck with that. So that's a serious issue. Every time we want to build a bigger and bigger solar farm, we start to run out of land. Then another aspect is land starts to absorb thermal radiation, basically optical radiation that comes from our sun, basically from visible spectrum. Then it gets absorbed by the land. Then land re-emits that in infrared, which cooks the solar panels. So solar panels do not like to be hot, which is ironic, but they generally like to be as cold as possible. Ideally 25 degrees Celsius. All the power rating has been done at 25 degrees Celsius. So but let's be realistic, in India, if you are, would be very lucky if you can achieve around 40 degrees Celsius. Most of the time it will be at 50 or 60 degrees Celsius. So photovoltaics don't like that. Then we have to understand the importance of water. We want to preserve water, specifically inland source of water we want to preserve. And then we need a lot of solar. It's like India is creating solar farms like there is no tomorrow, and that's amazing thing. Like India went from like the basically renewable energy mix of India. It's really good given the fact that we have 1.5 billion people almost. Our basically renewable energy sector is surprisingly huge. Now primary reason for that is we have huge amounts of hydropower, but again solar is also gaining a lot of ground. So government went from we are opening 10 megawatt solar farm to 2 megawatt solar farm to 200 megawatt solar farm to 600 to 2300 megawatt solar farm system, and even hundreds of megawatt power plants are being opened at this moment in time. So we are creating a lot of solar and we need even more. So land is a serious issue here. Now, the logic behind putting solar panel on top of water is basically we have a lot of inland water bodies. What does that mean? That simply means every large hydro dam has a huge reservoir. Every large thermal power plant generally has a huge water reservoir. Basically, we have more than enough water reservoirs that we, in terms of surface area, we have more than enough. Like, don't worry about it. That's kind of surface area we have. Then we have to understand these places consume water, either in terms of irrigation, in terms of basically industrial development or things of that nature. So losing that water to evaporation, it's an basically loss. It's a tangible amount of loss. And if you want to be efficient, the first thing you want to be is make sure you are not losing anything. So covering a giant water body is financially viable. It's like cover that puppy up and you will get basically savings in water. That's tangible. And if you put solar panels on top of that, basically you create you have a structure, you put solar panel on that. Solar panel is so close to water, it will remain cooler. Now of course it won't be at 25 degrees Celsius in India, but it will be much cooler than it would have been on land. So in land, worst case scenario, it would have been, let's say, 60 degrees Celsius. On basically solar panels that is very close to water surface on a large water body, it will barely reach 30 degrees Celsius. So in terms of power output, you will get much higher power because basically voltage of a solar cell directly drops compared to the temperature rise. So at 0 degrees Celsius, it's producing a lot of energy, but people understand that unless you live in Antarctica, it's not going to happen. Then at 25 degrees Celsius, that's how the power rating is done. India, 50 degrees Celsius, really hot places, 75 degrees Celsius. So water body is like, it will keep you closer to 25 degrees Celsius. So that's why people want to have water. And because the water body is covered and so solar light is not directly hitting it, its evaporation loss has been cut in very drastically. Like the amount of evaporation loss happens on large ponds are huge. Like ask anybody who builds a swimming pool. It's like, it's mind-boggling amount of water evaporates even on a large pool. So fundamentally covering that up is a beneficial thing. And again, covering something this large is a costly thing. So if it's making money, then it becomes much easier to do. Solar panels are making you money, so people want to do that. And these solar panels are generally will give you two advantages. First advantage is you're gonna save water, awesome. Second advantage is should at worst case scenario give you 5% more power. So basically if you had 100 megawatt system on land, it will give you 105 megawatt. Or if you are some scenarios where you have really high contrast, especially temperatures are really high, lands are really not suitable for solar farms, you could have 30% higher output. So if you had built 100 megawatt system on land, that would same solar cell, basically you take the solar panel, put it on top of water, you can get more much more energy output of that. So which makes it basically the expenditure of this puppy becomes far more digestible. So that's the logic behind it. Basically have two benefits: save water and also produce electricity. Oh, and so also the solar cells will live longer. The cooler the temperature, solar cells will live longer. So basically their degradation over 25-year lifespan will be much less. Now, how do we build that? Well, we'll start with water pontoons. These are basically plastic buoy, quote unquote. They are just injection molded unit with a very thick outer shell. And the idea behind is they are basically air inside them. And generally they are designed in such a way that they are very hard to basically puncture. And they have so many small units that puncture of 1 or 2 will not do anything to it. That's by design. So generally that's why they are small units. If you will notice that units are generally specifically targeted for one unit should be able to either act as a core unit meaning it will have the angle built into it, so you will mount solar panel directly on that and there will be connecting unit. That's how it's designed. Or you can have custom units which are like much higher buoyancy units which are specifically built, so it will act as a walkway, so you can walk on top of that, because again you have to walk there and you have to clean this puppy and you have to do the electrical wiring and all that. So you may have different units. One unit would be like, okay, this is for the panel angle. Another unit would be just a connector. Another unit would be for big units, basically where you have power connectors. You will have bigger units with higher buoyancy. Now be mindful, failure of any one of these equipment will not cause any harm. Inherently this sort of system have a lot of redundancy. Basically you have to like puncture many of the buoys, basically pontoons, before it starts to sink. So it's surprisingly robust, and we have built this for a few years at this point in time, so we know for a fact that these are long lasting structure. Basically they will not retire before the solar cells. And the plastics that are used generally are food safe, so even if they are put on a reservoir that is used for drinking water, it will not contaminate the water. Now units are basically either mounted very close to each other or spaced apart. Now spaced apart gives you the benefit of having the luxury of cleaning it easily, but packing them together gives you higher energy efficiency. So it's up to you, how do you want to manage it. And PV mounters are tried to be as close to water as possible. Now you may be like, wouldn't you want it to be like high up? Well, no, you want it to be as close as possible. And all the cables, basically in terms of photovoltaics, they are DC producers, and when you are talking about long string, you can have very high voltages. Some scenarios voltage could be 100 volt DC to around 1500 volt DC, which is so high that if it touches you, insta death will happen. So fundamentally speaking, all the cables have to take special precautions, and some pontoons have literally a cable gutter built into that plastic mold, so you're supposed to route the cable there, because if cable goes into water, if you're lucky, you will blow up inverter. Unlucky, some person would be in the water body, and because this is DC, it is very lethal. So all the cables have to take some special precautions, and there will be a special way to anchor the cable, so to say. And then the whole unit is anchored, because solar panels, while they are physically robust, they are still fragile, simply because again silicon structures are fragile, glass is fragile. So if you have a lot of waves going in like this, it will damage the unit. So generally you have to anchor this puppy, and that's why we generally prefer to use them on stable kind of water bodies. Reservoirs are awesome for that. So that's how we build these things. Now, what about the location, where you can find the location? And that's the whole thing. The first thing you will think about, if I say about water body, you will think, what about sea? Well, it can be done. Physics is not saying that it can't be done. It's just that it's too unstable. Basically, let's find a patch of 1 kilometer square of basically water body on sea. Any place on the sea will never be as stable as compared to basically reservoir water. So fundamentally speaking, everybody wants to put it on inland, not in sea. Can it be done? Yes, but problem on sea is it's too unstable, so you will have much higher degradation of physical degradation of all your equipments, and corrosive nature of salt water, which is very destructive. Like things that could easily last let's say 25 years on normal freshwater body will barely last 5 years on seawater. So that's a very serious thing. So your cost will go too high, and right now the target is for all these sort of plants is roughly around 10 crore rupees for 1 megawatt, or lower than that. The lower the better, but 10 crore is the upper limit, and I have never seen even a projection that achieves that kind of thing on sea. On sea you will be spending 2 or 3 times more than that. So that's a serious issue. That's why sea is right now, at current generation, nobody is focusing on that. and we have a lot of huge reservoir. This is one thing that I did not realize. Like most people have no context of it. What is the size of basically water reservoirs that we have behind dams? Like these are multiple square kilometers of area, not one, not two, multiple square kilometers. Basically you have 12 square kilometer, 35 square kilometer, you have lot of area. And looking at this, Indian government is planning to build a system that is world's largest, as in around 600 megawatt of floating power. Let that sink. 600 megawatt. China has the world's largest at this point in time, and that is around 150 megawatt. And they also have a lot of space, and they keep adding more solar panel to it. So India is directly targeting for that. So reality is we have a lot of huge reservoir, and saving water in these reservoirs is actually beneficial because these water are consumed for irrigation also. So even though you're not gonna directly use it for drinking water, the irrigation water saving billion liters of water from evaporation, that is really awesome. That means your summer will be far more manageable, summer drought, so to say. So that's a win-win scenario. You have a lot of land which government have already acquired. Nobody is living there. You do not have to displace people. And in case of power dams, there is one in Indonesia. They are doing something amazing. They are like, dams generally have a sluice gate that allows them to control the input and output. So they are like, hey, during daytime, solar power farm is producing the electricity. They are toning down the generator output during day. At night, they open it up. So they can, using same substation, they can provide more than enough power. They do not even need to create new independent substations. So that's amazing. Saving water, and even small units can be made. So be mindful when I'm talking about these things. These are like 600 megawatt, and minimum is like 1 megawatt or 5 megawatts. That's not necessary. Like in some rural communities, specifically in India, you could have a scenario where you just have one pond and people just put a solar panel on top of it and everybody is happy. Because some places in India still at this point in time has not been connected to electrical grid, so they do not have any semblance of power. So if you're gonna tell me, hey, I'm gonna do this thing and I'm gonna give you one LED light, one 10-watt LED light properly, they will be like, shut up and take my money. So that's the reality of it. Many places you don't even need huge reservoirs. Like to just make positive changes in people's life, you can do that with small ones. So what we can expect in the future? Well, this is one of the things that we have learning at this point in time. This is not something that you can, okay, in 1950 they did this. It's like very, everything around this is very new. So consequences, bird. There is a lot of bird. Like when Britain started to invest in this, like they were blown away the amount of garbage is going on solar panels. Like blown away about the shit. It's like so much shit is on this. So this is mind-bogglingly amount of like serious amount of time. And be mindful, these things are reactive. Basically poop is reactive. If it keeps falling on your panels and you don't clean them very quickly, they will literally erode away the glass and could damage the system and cause hotspots. So it is something very serious. Like these panels, if this farm is not cleaned very quickly, yeah, the end of this farm. So they learned it very hard way that you have to figure out a way to make sure birds are not an issue there. Where some people are thinking about having a loudspeaker that creates a certain sound that will keep them away. Some are thinking about lightning rods that have giant cable on there, because bird generally does not like the idea of flying below a cable. Again, there are many options that are people thinking about, because bird is a serious issue. So that's one thing you have to handle. Then corrosion. You are talking about water. So water is very universally corrosive. So even if you put, let's say, galvanized steel, over time it was gonna corrode. Of course, it's not gonna corrode overnight, but it will corrode over time. So you have to be mindful about that. Then we come to safety and maintenance aspect of this, because be mindful, so people have do not take solar panels as seriously as generator, for example, but these puppies have DC energy, and if you have a large string of them, they are more than powerful enough to instantaneously exterminate people instantaneously. So we have to learn these things. And because while solar farms are becoming big thing now, and we have been building enough of them for, let's say, last 20 years, that we have some idea of like how the heck we can manage accidents, how the heck we can prevent this or that. In terms of floating system, we are very new, so we are writing the book as I speak. And this is one of the solar farm. I have read the video down below. It's amazing to me, because these are built from NRIs, basically Indians who went abroad, and they went to Singapore, I think, and they came back, and they are like their hometown basically was very remote village that is not even have connection to the grid. So they are like, okay, they had a water pond, and on top of that they built this, and they did not even had money for pontoons and all that. So they used PVC pipes, basically large PVC pipes, and seal them up to acting as a pontoon, and they had solar farm there. And people love it simply because, think of it this way, like we take electricity as like, oh, I don't have few kilowatts of energy, I don't have the luxury of running my air condition. Compared to people who have never touched electric grid, they're like, dude, light bulb, what magic is this? So for those sort of people, this system was surprisingly welcomed, so to say. People loved this fact. So looking at the success of this pilot project, government is like, shut up and take my money. So a lot of projects have been under development at this point in time, and then 600 megawatt is the largest that is like I know of that Indian government is pouring a lot of money into it. Now India's renewable energy mix is improving by a lot. Like given the scale of our country, the energy mix is surprisingly good, as in like we are the second largest population on this planet, and the fact that we have like at least 30% renewables, that is good. So and on top of that, solar is taking even bigger and bigger chunks. So I see a lot of potential into this, because India does have second largest renewable energy provider is hydro dams. So having giant basically floating solar farms behind dams is awesome, and on top of that, dams already have electrical infrastructure built for it. So it will allow us to utilize all our resources efficiently. So I see a lot of potential in this puppy. So this is one of my presentation on floating solar. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.